Hello and welcome back to Technology Now, a weekly show from Hewlett Packard Enterprise where we take what's happening in the world and explore how it's changing the way organisations are using technology. We're your hosts, Michael Bird
and Aubrey Lovell. And in this episode, we are looking at a new level of security in cloud storage, bringing the cloud to the user. We'll be exploring the different types of cloud computing which exist. We'll be looking at what it means for a cloud to be cut off from the internet and how this is even possible. And we'll be asking why organizations might want to do this.
Yes, absolutely. And if you're the kind of person who needs to know why what's going on in the world matters to your organization, then this podcast is for you. And if you haven't yet done so, do make sure you subscribe on your podcast app of choice so you don't miss out.
Sidebar, I want to give a shout out because I actually used to work on a cloud team in HPE. So I love talking about private cloud, public cloud, multi-cloud. I used to do that back in the day, so very exciting.
So this episode is for you as well.
It is, taking me back.
All right, let's get into it. Cloud computing is everywhere, and it's ingrained so deeply into the modern world that a 2024 forecast from Gartner predicted that global spending on public cloud services is expected to surpass $723 billion in 2025, with 90% of organizations adopting a hybrid cloud approach over the next few years. And we've linked to both of those stats in the show notes.
But how did we get here? Well, modern-day cloud computing, which is the practice of hosting your network or personal files on a remote server, has been around since the early 2000s, where it provided huge benefits to smaller businesses. The success of the cloud computing model saw it grow rapidly over the following decade, with providers from all over the world popping up to compete to host people's data. From entire company networks down to photos of your cat, which, by the way, I'm on Team Dog. When your phone memory is already full, anything could and was kept on the cloud as we know it. But how safe is the cloud? You're literally entrusting someone else to protect what's yours, but you don't really know how they are doing that. It wouldn't be very clever for a company to publicly explain exactly how its security systems work, so most of us have to take them at their word that our data is safe. But here's the problem. What do you do when someone's word is not good enough?
Yeah, I don't know.
Right? Because if you're opening a door to get into your own servers over the internet, like what's stopping someone else or something else from slipping in behind you?
Yeah, agreed. And what do you do when you're in a position where regulation or security concerns require your cloud to be completely inaccessible to those outside your organization? And also, how do you increase the security of your cloud to take it off the internet entirely without giving it up altogether? I don't necessarily have the answer, but joining us in today's episode to explore the issue is Rich Bird, no relation, and he's the worldwide product marketing manager at HPE, who can help us unravel the paradox of how you can disconnect a cloud. Rich, welcome to the show.
Thank you for having me.
So let's just talk disconnected cloud then. It's a bit of a paradox, isn't it? Can you just sort of explain what's going on there?
Yeah, sure. So to me, some of the more interesting things in our life, like the way we define things and the way we adapt to things, are really around those oxymorons, those two things that can't really be true at the same time, but they work by design, by their nature, like strategic unpredictability or controlled chaos or deafening silence. It's interesting that this concept of a disconnected cloud really fits within that realm. Over the last 5 years, we've really been engineering this system that kind of moves at the speed of intelligence of connected systems whilst remaining sovereign and sealed and unbreakable, disconnected from the internet. And it's not just a theoretical solution. It's one that's tested and validated in real world productions before we bring it on-prem. And we've built this for some real specific organizations around the world, right? So defense, critical infrastructure, sovereign governments. It doesn't just work in their controlled data center, but it works, on land, at sea, in the air, and it's rigorously controlled within national borders, right? That's a key concept with sovereign, because those mission critical environments need that cloud experience on-prem, the security, the sovereignty, over not just the data, but the data that they use to run that infrastructure, but they need it without reconnecting to the internet. And that's one of the key differences with this solution. It can run unconnected from the internet forever.
So, Rich, just to confirm, when you say on-prem, you're talking about bringing this cloud onto the premises of the user?
That's right.
Got it. Okay. How does it differ from what most people would think of as the cloud?
I'll talk to customers and partners about this all over the place. And when we talk about disconnected cloud, kind of a blank look comes across their face, because we all know cloud to be connected. It is resources in another location that we use to achieve our organization goals, our mission goals, or to deliver some kind of value to an end customer. And traditionally, well, people usually go straight to public cloud. And what we're saying with this is that we're going to bring those public cloud resources into the customer's network. And what gets disconnected is the management platform. So we bring the software from the public internet and essentially install it on-prem so they can get the full capability of cloud-like operations without needing a connection to the internet.
Right. So how does this differ then from a private cloud? Because I thought a private cloud, I mean, that's been around for years. So I thought private cloud was sort of that. Have I got that wrong?
No. So I don't want to get too technical, but we have to get into the definition of private cloud.
Go on, let's get technical.
So the characteristics of a cloud, now this is via an organization called NIST, National Institute of Standards and Technology, and this is globally recognized. So when I think the traditional private cloud, it is your on-prem infrastructure that you have teams running, and it is a traditional way of working. But when we look at private cloud from a modern perspective, it has to have the essential characteristics of being an on-demand self-service. So we have a pool of infrastructure that you can use for different purposes, essentially. You have to have broad network access, which means that everything's connected to everything else, right? We kind of assume that from a traditional and a modern perspective. Resource pooling. So again, right, that's where you've got the physical hardware, but you can split that up into different, I'll say regions, but that's got some specific connotations that we'll perhaps get into later. But you can essentially share the physical resource from a virtual perspective with different resources. And the next thing in that is rapid elasticity. So you can assign resource to one workload and then to another. You can scale it up and you can scale it down. So it's really flexible and scalable from that perspective. And then it all has to be measurable. So that last characteristic is measurable. And we can see this in the public cloud where companies receive a bill at the end of the month. Wouldn't it be cool if, from an IT department perspective, that you could bill the different departments across the company for the different amounts of uses that they've had from that underlying infrastructure? So that's the difference between a standard private cloud and a modern private cloud that has all of those essential characteristics.
So what's the market for a disconnected cloud? Who's buying it?
So probably a decade ago, when we started seeing a move to public cloud, the end user is asked not to know where anything is. They're asked not to know where the underlying infrastructure is, the servers, the storage of the network. They're asked not to know where the software is installed. And they're asked not to know where the people who are managing that infrastructure are. And that is very useful if you've not got any definitions of where it needs to be, who needs to have access to it, and what it needs to be. But organizations that need to know all of those things, what is it, who has access to it, where is the software, where's the software calling out to? It's organizations like that that really need that on-prem private cloud and the governance and control that it gives with them, but then also that the functionality and the capability of that modern private cloud within their network. So we see some defense organizations, some national infrastructure organizations. We see some financial services customers that want to have a piece of their network that can run modern workloads, but can also operate disconnected from the internet. It's highly regulated industries that need to know where their things are, whether that's the software, the hardware, or the people that are delivering that service.
So there's an element here of data sovereignty. So, it's super important to know where everything is. And is that from a regulation perspective? And are we seeing that increasingly more and more these days?
Very much so. So you said the magic word. sovereignty. So that means a couple of different things within this context, right? So we all, well, I don't know whether it's a well-defined term, but we've all got an idea of what sovereignty means. It is being able to make decisions that you have control over. With data sovereignty in the cloud, or digital sovereignty to take it to that extra layer, it is having confidence that all of that resource that I talked about before, right, hardware, software, services personnel, are all within a predefined sovereign region. So the sensitive data that might be kept, or the sovereign data that might be kept, again, we need to know where that is. We need to know who has access to it. And that's really around sovereignty. But there's like another layer of that when it comes, you've got a technical audience, right? So data sovereignty, there's two things. There's the actual data, but then there's the data around the operations of the cloud. So all of those characteristics that I talked about, elasticity, pools of resources, that is also data that needs to remain sovereign under control of the customer or the partner that we're working with.
Thanks, Rich. There are some amazing insights in there.
Right then, Aubrey. Now it is time for Today I Learnt, the part of the show where, of course, you and I take a look at something happening in the world that we think you should know about. Aubrey, I think it's your turn this week. What do you have for us?
It is. I'm putting on my reading glasses. Okay, so this could be a moment for the history books. We might be about to witness a discovery that rewrites the science of the universe as we know it. Gosh, this is a lot of pressure, guys. Okay, so today we are talking about the Big Bang Theory, which is the idea that everything expanded out of a single point, leading to where we are today. It's the standard accepted theory of how the universe literally came to be in its current state. Now, over the years, this theory has been tweaked and refined with extra discoveries and additional theories to explain observations astronomers have made, including concepts such as dark matter and dark energy, which explain why galaxies are the shape they are and why the universe is still expanding.
I'm nodding like I know what you're talking about. Yes, I know it very well.
I feel so smart right now. I got my glasses on, like I'm living.
This is the first time you and I have ever had a conversation about dark matter and dark energy.
I love it, and it's very fascinating. In fact, researchers from DESI, that's the Dark Energy Spectroscopic Instrument Collaboration, have presented results of a long-running experiment which could potentially upend the standard model of cosmology. Dark energy is changing.
Ooh.
That sounds weird, doesn't it?
Ooh, very much does.
According to the study, measurements from DESI show that the acceleration of the expansion of the universe might be decreasing. So think of it like easing up on the accelerator of your car. You're still speeding up, but at a much slower rate. This discovery, if further investigations prove it true, would mean that the cosmological constant is, well, not quite as constant as we once thought. The findings from DESI haven't quite hit the reliability level needed to describe a discovery as genuine. However, researchers believe that they could reach that level within only 2 years.
Well, thank you for that, Aubrey. I'm going to go sit in a dark room and contemplate my life choices. That was... that slightly melted my brain.
But while we wait for scientists to let us know if all of our astronomy courses globally need to be rewritten, let's return to our guest, Rich Bird, to explain what a disconnected cloud would actually look like in practice. Back to you, Michael.
So, Rich, if you had a disconnected cloud, your organization wouldn't just have that as their infrastructure. This would form part of a fabric of different types of clouds. An organization would have maybe a disconnected cloud, some workloads on a disconnected cloud, some workloads on a private cloud, some workloads in the public cloud, and they would all sort of work together somehow.
Yeah. So it's a really interesting question around hybrid cloud and how over the years, like I said, over the last decade, some organizations have choose to move to the public cloud, but some things are kept on-prem. So like bursty data, I'm going to say, right? So what does that mean? That means you're looking to set up a customer interaction, an application that manages customer interaction. You don't know whether that's going to be high traffic, low traffic, or what point in the day.
Right.
That is a good workload for the public cloud. But when we start to think think about the things that we all need to be kept safe, right? Personalized data, mission data, that is an excellent candidate for that disconnected cloud option. So you can keep it not just behind the firewall, right? Because that is still connection. It's the firewall that's stopping specific traffic going from one network to the next. But when we think about data security and operational security in that disconnected world, it's completely disconnected from the internet. Now, we have got capabilities that help our customers manage that hybrid operation, so managing workloads in the cloud and on-prem. And then what we've done from a disconnected perspective is take that software that we developed in the public cloud and it runs in the public cloud and it's tested and validated in the public cloud. We then install that on-prem. So it's tested, it's validated, we know that it works, we know that all of those essential characteristic works, but it is disconnected from the internet.
This might sound like an obvious question, but does a disconnected cloud provide better resilience against things like cyber attacks, ransomware, that sort of stuff?
I'm going to say yes, because it is a physical, so we call it air gapped, right? For a reason. So what is an air gap? And my mind always goes to like chip fabs. So they're dust-free environments. So you have to go into a room and then into a second room that blasts all of the dust from your clothes before you're allowed access into the network. This is that air gap, which is blowing the dust off the people's clothes. That's the same here. So from a security perspective, when we deliver this as a service, it is security cleared local nationals that have access to this infrastructure. So it's that extra layer of security, right? So we've got the physical secureness because it's completely disconnected from the internet. So you need access to the building and to the machines themselves. But then the people that have access are also security cleared, they've all got their validations. They all know the software that they're working on. So it is trust on many different levels. Trust from a disconnected perspective physically, and then trust from the people that have access to the infrastructure from a regulatory perspective.
So let's maybe just get a little bit into the weeds here. Like, how exactly does a disconnected cloud work? Like, how is it physically different to, a private cloud on your own infrastructure?
Yeah, sure. So the key thing is the software that we use to manage that infrastructure. We've got a piece of software that we've developed over the last 10 or 15 years called HPE GreenLake. So HPE GreenLake is software that the customer logs onto to set up new users, to provision VMs, to monitor their systems, to look at we've got some really interesting things around sustainability, like which one of your data centers is the most efficient and can we move workloads there? So it's that GreenLake cloud platform that we have running in a public environment for managing the infrastructure. What we do is take that down and install it inside the customer's network. So all of the APIs, all of the different capabilities within that software that is a cloud-like piece of software, it's actually installed within a customer's secure location that nobody has access to, or their specific data center that has the physical security wrapped around it.
Yeah. So do you think sort of this disconnected cloud will be the future of cloud? Like, are we barreling towards a future where every cloud is disconnected?
To me, it comes down to people, right? I'm an ex-engineer. I was a network engineer. I always wanted to work on the latest, the newest thing. And over the last 10 years, we see a lot of the people, a lot of the app developers, a lot of the people working on this infrastructure have wanted to move to cloud. They've wanted to go over there and, get the accreditation and the jobs to modernize applications. And when we look at government and defense, right, they need modernization and they need access to the resources that have moved to these cloud first principles. What we're doing with this solution is bringing those cloud principles on-prem into the private cloud, which also brings with it access to all that talent, all those app developers, all of those people that are keen to modernize things into the private cloud, which I think is really exciting.
So let's take this to the user, because I guess user experience is key these days. Would a user be able to tell that what they're using is on a disconnected cloud? Or am I getting the wrong end of the stick here?
Well, we would hope, right, that the users wouldn't notice because it runs, it's there when they need it to. If the internet connection goes down, this still works because it is designed to do that. They wouldn't notice any difference, but they could have the additional confidence of the security and the regulatory needs met by a solution like this.
Thanks so much, Rich. It's been great to hear from you, and you can find more on the topics discussed in today's episode in the show notes. All right, well, we're getting towards the end of the show, which means it's time for This Week in History, a look at monumental events in the world of business and technology, which has changed our lives. Michael, what was the clue last week?
Well, the clue last week was it's 1918 and the United States is springing forward into a new age. Aubrey, what did you think it was?
I thought it was daylight savings time. Am I right?
Aubrey, you are absolutely spot on. Because yes, you're right. It was the introduction of daylight savings in the United States on the 31st of March after the establishment of the Standard Time Act in US law. This was a big event, right? Huge crowds gathered to watch the clocks on the Metropolitan Building in Manhattan have their hands manually moved an hour forward. I'm not sure that would get big crowds in 2025.
Definitely not. But back then it was all the rage, I'm sure.
One reporter at the time described the scene as the crowd rubbed their eyes and marvelled at the novelty of an Easter Sunday of only 23 hours. The act was repealed only a year later, with daylight savings becoming a matter for states to decide for themselves before control of US time was once again returned to Congress during the Second World War. Daylight savings has undergone multiple changes and to this day is still a controversial topic, with several states considering scrapping the practice altogether. There's daylight savings in Florida where you are, isn't there?
Oh, yes. And let me tell you why it's a problem, right? Because when you have these fluctuations in springing forward or falling back, especially in, the time of year it is, you lose so much sun. So like in Florida, it'll get dark at like 5 p.m. or light, just the opposite effect, right? So when, like, for example, the routines you have with walking your animals, getting up in the morning, it completely screws everything up. So I am definitely on team, getting rid of it. But I totally understand the context as to why we still have it. I mean, obviously, we had it in the beginning because it helped farmers, right, with harvesting crops and agriculture. But with today's technology, we really don't need it. But I'm sure there's a case that people still would want to keep it.
You and I both care about it. Lots of people care about the single hour of daylight in the evening. Aubrey, what is next week's clue?
Okay, so our clue for next week, and it's a recent one, so we're moving up in time here.
Lovely.
It's 2019, and science has answered the question, how do you take a photo of something which is completely black?
Oh my goodness.
I don't know. I mean, you would think it's recent. We would know this, like, oh, okay, this is like pop culture or something. And
I don't know.
I don't know.
No. Well, I guess we'll find out next week.
Indeed. Well, that brings us to the end of Technology Now for this week. Thank you to our guest, Rich Bird. And of course, to you, our listeners, thank you all so much for joining us.
Yes. Now, Technology Now is hosted by Aubrey Lovell and myself, Michael Bird. And this episode was produced by Harry Lampert and Izzy Clark, with production support from Becky Bird, Alicia Kempson-Taylor, Alyssa Mitri, and Natasha Nike.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a fresh air production for Hewlett Packard Enterprise, and we'll see you at the same time, the same place next week. Cheers.